Before we do example 2, I need to go back because I was like, oh crud, I misspoke earlier, but it wasn't worth me recording the whole video. I want to go back 2 slides. I said this is good for SAS, side angle side, but it's also good for side, side, side. In example 2, that's what we're about to interact with. So, on example 2, we're given a triangle ABC. We're told the 3 measurements are A equals 8, B equals 9, and C equals 7. So, draw a triangle, try to make them 3 different side lengths. It's not the best, it's not the worst, it's going to be okay. Looking at this, our longest side on the bottom there, it looks like, I'll call that the longest side, so that's going to be B. The shortest side was C, so 7, and my longest side is A equals 8. So by default, this would be angle A, this would be side B, and this would be side C. Now, just like on the previous one, so this one we have all 3 sides. This one I'm going to say solve your smallest angles first again. So since side C was the smallest side, we're going to solve the smallest angle, angle C. So that means we're going to use the equation that uses angle C. So we're going to use that bottom version, the C squared equals A squared plus B squared minus 2 times A times the cosine of C. So let me write that out again. So we're going to use C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Holy cow, that's a lot. Man, I hope we only have to use that once in this one. Don't worry, we will. So let's plug in what we know. C, we said was 7, so we got 7 squared equals A is 8, so we got 8 squared plus our B value was 9 squared minus 2 times 8 times 9 times the cosine of, we don't know angle C. That's the only one we don't know. Cleaning this up a little bit, 7 squared is 49. 8 squared, 64. 9 squared, 81. 2 times 8 times 9. Well, 8 times 9 is 72, so times 2 is 144 times the cosine of C. Now, I'm going to kind of do 2 steps at once. 64 plus 181 is 145, but let's just subtract that 145 from both sides. 49 minus 145 gives us negative 96. On the other side, that's going to cancel out. We're going to be left with just negative 144 times the cosine of angle C. Let me start zooming in on this. I'm kind of zoomed out a little bit. So we're still trying to solve angle C. We got to get rid of that negative 144 first. So what we're going to do is divide both sides by negative 144. Now this one, conveniently, if you type that into a calculator, it's going to give you 0.6 repeated, which is going to be 2/3 equals the cosine of angle C. Now we haven't dealt with this in a couple of days. How do we get rid of the cosine? Well, the best way to get rid of a cosine is to take the inverse cosine. So I'm going to take the inverse cosine on both sides. So on our calculator, we'll type in the inverse cosine of 2/3, and that'll just give us the angle C, which ends up being 48.2 degrees. So let's label that 48.2 degrees. Honestly, that looks like it could be around 48.2. Not bad. Okay, as I said earlier, let's work on solving the smallest angles first. So looking at this, our options, we solved the smallest angle. The next smallest angle, we got to look at the next smallest side. That's going to be the A equals 8. So let's find angle A here. So to find angle A, we could, emphasis on could, go through and redo the law of cosines using A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Goodness gracious, that's a lot of work. My advice is, once you have an angle, use the law of sines. So we're going to say the sine of whatever angle A is divided by side length A is equal to, well, now we have another angle measure. The sine of 48.2, that's angle C there, divided by 7, side length C. So again, for clarity's sake, this is lowercase a, this is capital C, we got this from lowercase c. So to start solving for angle A, we've done this process several times before. We can cross multiply. 7 times the sine of A equals 8 times the sine of 48.2. To solve for A, we got to divide both sides by 7. I overcomplicated that. Whatever, it's fine. We got the sine of angle A. I just took an extra step we didn't need to. Equals 8 times the sine of 48.2 over 7. Really, what I should have done at the beginning, I wasn't thinking ahead. I should just multiply this whole thing by 8, and we'd end up with this anyways. My apologies. But the last thing we need to do is the most complicated, because now we got to type into a calculator. We got to take the inverse sine of both sides. So on the left side, we get angle A. After we go through, again, you can take it piece by piece in your calculator. Just have the calculator keep track of the work for you. We get A equals 50, forgot the negative one there, 58.4 degrees. So angle A, 58, there we go, 0.4 degrees. Now we still need to find angle B. Thankfully, we have the two other angles. So we're going to take, to find the measure of angle B, we're going to do 180 minus the two other angles. So minus 58.4 and minus 48.2. And we end up with a measure of angle B equals 73.4 degrees. So let's write that. 73, sorry, flip that around. 73.4 degrees. Now double checking, does our answer make sense? Well, is the largest angle opposite the largest side? Sure is. Is the smallest angle opposite the smallest side? Yes, it is. Cool. Let's try one last example. So a pilot is flying from Houston to Oklahoma City. To avoid the thunderstorm, the pilot flies 28 degrees off the direct route for a distance of 175 miles. He then makes a turn and flies straight to Oklahoma City. To the nearest mile, how much further than the direct route was the route taken by the pilot? In other words, the shortest route he could have taken was from Houston to Oklahoma City, so that's the shortest route. That's our shortest route, 396 miles. Instead, the pilot took this route, and then they turned to go that way. We essentially got to figure out how much further that is. We know it's 175 miles in that portion. We just got to figure out that. So we just need to label these. Just for kicks, I'm going to label Oklahoma City A. I'm going to label the turning point, wherever they turned, as B and Houston as C, which then we're going to label the opposite sides. So the opposite side of B, the 396, that's lowercase b. Opposite of A, it's kind of hard to see from this weird angle, but that's down here, and we're just going to be looking for that little guy there. So if we're looking for that length there, what we can do is use the law of cosines and say c squared, that missing side squared, equals a squared plus b squared minus 2 times a, I don't know why I put that in parentheses, times a times b times the cosine of angle C. We happen to know angle C, so that's really convenient. To find C, what we're going to do, again, plug in those values. So we got 175 squared plus, yikes, 396 squared minus 2 times 175 times 396 times the cosine of 28. Oh my goodness, folks, that seems like a lot of numbers. 175 squared, first of all, would be like almost, well, the second simplest calculation. Most of us probably can't do that in our heads, myself included. So what I'm going to suggest we do, taking a look at the big picture, we're trying to get C all by itself. So we're going to have to take the square root of that side, and we're going to have to take the square root of whatever that is. And again, you can type that into the calculator exactly as it is. And on the left side, we're just going to get C. On the right side, after typing that all in, making sure we're rounding correctly, because we're asked to do this to the nearest mile, we're going to get 255 miles. Now, that's not the final answer. We should always go back, even once we think we're done, we should always go back and read the question. The final question says, to the nearest mile, how much farther was the direct route, or how much farther than the direct route was the route taken by the pilot? So let's label that length that we just found, 255. So the total distance they went, the total distance that pilot traveled was that 255 that they just did, plus that 175 that they initially did. That gives us a total of 430 miles. So in other words, they went a total of 430 miles. Again, that's still not our final answer, because it says how much farther. Well, they should have gone, like the shortest path would have been 396. They went 430. So what we can do, let's just take 430 and minus 396. And we end up with 34 extra miles. They went 34 miles further, which when flying, it's not that bad. So they went 34 extra miles. So always make sure you're rereading the final question, make sure that your final answer is actually answering the question.